Okay, first I'm going to simulate 50 births by randomly generating 50 integers between 0 and 1. So to do that in StatCrunch, I'm going to click on Data and Simulate Data and Discrete Uniform. Okay, so I want to generate 50 rows in a single column. Now your actual lab assignment has you generating 500 values, so you're going to want to change that to value to 500, not 50. The minimum value is going to be 0 and the maximum value is going to be 1, where 1 represents a girl. And I'm just going to leave everything else on the screen as is. You don't need to change the seating or anything. Click on Simulate, and you can close out this window, and you'll see that in your first column you're going just to have a random set of 50 integers of 0 and 1. So a quick way to get a count, because in your particular problem you want to count the number of girls, so you want to count the number of ones, I'm going to go click on Stat and then go to Tables and click on Frequency. I need to select the column and click on Calculate. And you'll see that it tallied the number of zeros and the number of ones. So for this set of 50 values, I got 28 zeros and 22 ones. Now when you're doing your lab, it's not likely that everyone's going to get exactly the same values, exactly the same number ones as everyone else, because we are sampling in a random manner. And over here there's a relative frequency table. In other words, this relative frequency of 0.44 is going to be 22 divided by 50. So actually this column here is giving you your empirical probability or your relative frequency probability. Okay, I'm going to go ahead and delete this column. You don't have to do this part. Okay, just clearing that out. Now for this next example, I'm going to have the software simulate rolling a single die 50 times. The steps are the same. I'm going to click on Stat. I'm going to click on Data and scroll down to Simulate Data. And again, I'm choosing Discrete Uniform. Discrete meaning that we're taking on a countable number of values within an interval. I'm going to simulate rolling my die 50 times, so I want 50 rows in one column. Now this time you don't want to put in 0 for your maximum value and 0 for your minimum value and 1 for your maximum value. In this case, you want to put 1 for your minimum value and 6 for your maximum value, because you're simulating rolling a 6-sided die. Okay, so again, I don't need to change anything down here. I'm going to click on Simulate, and I'm going to close out this window. So you'll see that my first column is just a random sample or a simulated experiment of rolling a single die 50 times. So in other words, on my first roll I got a 3, my second roll I got a 1, my third roll I got a 1, and so on. So again, to count the number of times each phase occurred, I'm going to click on Stat, scroll to Tables, and click on Frequency. Again, we need to tell it what column, and click on Calculate. So you'll see that your first column lists all the outcomes, okay, the 6 faces of the die. On this particular random sample, I got the face to be 1 13 times. So this relative frequency is calculated by taking 13 and dividing that by 50. And then for this probability experiment, the outcome of 2 occurred 8 times. Now you'll notice that these aren't occurring with the same frequency. Rolling the die 50 times is somewhat of a relatively small experiment. If we were to roll this die 500 times or 5,000 times, you should expect these values in the relative frequency column to be closer together. Okay, so again, everyone is probably going to get a slightly different relative frequency table. So these values are actually your relative frequency probabilities. Okay, so next thing I'm going to do is delete that column. Again, you don't have to do this step if you don't want to. Okay, so starting from scratch, I'm now going to have the software simulate rolling a pair of die. Okay, so again, I'm going to go to Data, Simulate Data, and I want Discrete Uniform. This time I'm going to do 50 rows, but I'm going to have 2 columns where the first column will be die 1 and the second column will be die 2. Again, I'm rolling a 6-sided die, so I want a minimum value of 1, a maximum value of 6, and I can just click on Simulate. I'm going to close out this command window, and I'll see 2 columns of 50 rows. Okay, so looking at this, on my first roll of the dice, I got a 6 on one face and a 3 on the other. For this next roll of 2 dice, I got a 3 on one face and a 4 on the other. So if I'm concerned with getting an experiment where I'm counting the case where the sum of the faces is 7, I can easily simulate that by taking each of these faces and adding them together. So what I want to do is have the software add each row together and put it in this column. So to do that, I'm going to click on Data and Compute Expression. This is going to save me some time. Rather than manually going down the rows and adding them together, I'm going to tell the software to do it. So what I want to do is literally tell it, take the first column and add it to the second column. Okay, so I double clicked on the first column, which I did not change the name of. I could have called it die 1, and then I use plus, and then I double clicked on the second column. Okay, so I'm going to click on Compute, and you'll see that in the third column you're going to have the sum of the faces. So in other words, on die 1 I got a 6 and die 2 I got a 3, so the sum of the faces is a 9. So if you're looking for a particular outcome, say the sum of the faces being 7, you can either visually go down and count how many there are. That would take some time, especially if you were rolling the pair of dice 500 times. So instead, I'm going to have the software tally it for me. Going to Stat, click on Tables, click on Frequency, and then I'm going to have it tally the outcomes in the third column, which is the first column plus the second column. Okay. Okay, so this first column represents all of the possibilities for the sum of the faces and how many times each occurred. So if I'm concerned with the sum of the faces to be 7, okay, here's the outcome of 7. That outcome occurred 10 times, and its corresponding relative frequency is 0.2. Now in your lab you're requested to find the theoretical or classical probability using techniques that are described in the textbook.